earlier class, we discussed the basic concepts of infinite series starting from the sequence. So when do you say a sequence is convergent? When it has limit. Sequence, I'm talking about sequence. For example, if actually we are discussing today about tests of convergence. It's not specified, but it is to be understood that I am talking about tests of convergence of infinite series. This is our topic of today's discussion. So let's have a short recap. If un is a very good sequence and Sn is equal to, you are making me very happy right now by telling that the background, right? Very nice. So Sn is like this. Then be careful, I am writing if here and I am giving the details of this. Then I am saying something. Bracket Sn, where Sn is defined in this way, is called infinite series. What is that infinite series? Also called which one? This Sn, also called sequence of partial sums. I am closing the bracket. Just an extra explanation here that it is called as a sequence of partial sums. What do you mean by that Sn when you define the Sn in this way? That is S1, S2, S3 is infinite. It's looking like E. So infinite series. Instead of writing like this, actually this is the expansion for Sn. What is Sn? S1 U1. That is U1 comma so on is infinite series. Instead of writing this, the very short notation is sigma un, n is equal to 1 to infinity. That is equal to u1 plus, okay, that is, this is infinite and this is very popular notation, means every time we will be writing like this. So only two things you have to draw the conclusion. That two things are, this is the background sequence, this is all how we prepare the new sequence and all these things. If un is a sequence, then sigma un, you leave this detail just to come to point that it is infinite series. These are all technical details. What is the conclusion to remember? If un is a sequence, then sigma un is called infinite series. I hope this conclusion is clear to you. So what is the final conclusion? If un is a sequence, then over sigma un is infinite series. You know that a sequence is called convergent if it has a limit. Now we are not much interested in the limit of this sequence. Keep in mind u1 comma u2 comma u3. This limit is not much important for us. What is much important for us is this new sequence u1 plus u2 so on. What is this? Tell me, is it a sequence or not? Yes. Full name for this is sequence of partial sums. And if we just change the notation, u1 plus u2 plus u3 so on is infinite series. From here onwards I will be just writing is. short form for infinite series. This infinite series, when it is convergent, when it is this it means this one, yes, when it is convergent, when then we define that convergent series. Convergent series. Whenever I write series, it is understood. Infinite series. So convergent series. If UN is a sequence, if UN is a sequence, then sigma U is infinite series. Is called means you are defining now only. Is called, this series is called convergent if bracket Sn is convergent. What is the point here? For this series to become convergent, what is the requirement? The sequence of partial sums, that is Sn, should be convergent. So this particular we are not interested. Sorry, not interested. Where we are interested? See, very good. Sequence of partial sums. So three things you have to very clearly keep it in mind. That is, there is a background sequence, there is a sequence of partial sums, and this is the infinite series. This infinite series will be called convergent if this second one, sequence of partial sums, is convergent. So we are interested in the limit for this one, this sequence. If there is a limit for this sequence, this is number 1, this is number 2, this is number 3. This number 3 will be called convergent if number 2 is convergent. We are not interested about this. I'll talk about that in next details, right? If it is not interested, why are we writing? The details are there, I'll tell you. So when this number 3 will be convergent? If number 2 is convergent. If number 2 is convergent, we will declare, but the main important point is, whether this board is coming fully? No? I'm not coming in this now? Okay, right. You do one thing, you take the screenshot of this. You take a photo of this one. At least one, somebody, just enough. Thank you, you are coming now? Right, you take it. Neatly. Thank you very much. So, understood this much? Now I have rubbed the board. Tell me what is our actual topic, where we started? Very good. Tests of, when you say tests of convergence of infinite series, the basic point is that you should understand what is the definition for convergent series. Then you will move towards testing. So you are clear, right? This is the point to be noted with a lot of care. That is, it is not easy to decide the convergence of how many of you catched, absorbed, understood this statement? So simple point what I am saying. It's not easy to decide whether this is convergent or not. What is this one? U1 comma U1 plus U2 comma U1 plus U2 plus U3 comma so on. It's not easy. But as per definition, when this will be called convergent? but sigma is okay, un is convergent if and only if this, okay, this is shortly written as S1 S2 if bracket Sn is. Are you able to understand one thing here, that the problem of deciding this is convergent or not, that is difficult. Therefore deciding that it is convergent or not, it is difficult. So we need alternate ways to decide whether the series is convergent or not. So we will develop certain techniques that are in the form of tests, plural I am saying, tests. So we need a test to decide the convergence of sigma un. When I don't write anything, it is understood that it is n is equal to 1 to infinity. So I will be dropping this and I will be just simply writing sigma un always. Now the point is, we need a test to decide it is convergent or not. Some test we will develop, but the test is developed on what background? Main thing, that is the definition. We have decided that it should be convergent, then only this is convergent. So using this concept of definition, we will prepare tests. Once the test is prepared, we will not use the definition, we will be using the test. I hope you are clear. So we will not be touching definition afterwards, we will be touching only or using only tests. So the first thing that is in the test of convergence, means convergence of infinite series. In today's session, we will be dealing with only 3 tests. First one is limit comparison test. Okay, and in short, I will be writing from here onwards LCT. And the full name of another test is D apostrophe Alembert's ratio test. Ratio test. Don't give always the names in the short form acronym like that. What is that? DRT. No need. We call it as ratio test. This is the name of a mathematician, D'Alembert's, right? And the third thing, that is Cauchy. You know Cauchy, right? What he was? Mathematician, simply you will mathematician, it's enough. So Cauchy's nth root test, that is shortly called root test. Okay, so now we move towards the first one, that is limit comparison test. Keep in mind, this limit comparison test will be used when un is, listen carefully, when un is like f of n by g of n, means numerator f of n, denominator is, and both are polynomials. It is not limited to this. Means only when polynomials are used, you have to use this, not like that. But when polynomials are there, we will definitely use limit comparison test. In some other situations also we will be using limit comparison test. We will see in the problems how in other situations also this test can be used. So basically we use this test when f of n and g of n are polynomials. What is a polynomial? Anybody in the class? What is a polynomial? Better I will make a part of this work, that is polynomial. A function of the form f of x is equal to some constant a naught, constant, whatever constant it is, some other constant a1 into x plus a2. Are you able to note that I am using only integer powers, fractional powers I am not using, negative powers I am not using, only x power 0 is allowed. So 0 is allowed, 1, 2, 3, 4, so on. But it should stop at some an x power n. Be careful here. It should not be infinite series. If it stops at some an x power n, then only it will be called as a polynomial. This is the actual definition of polynomial. But in our case, we are using the variable as n. So tell me some polynomials in n. 1 plus 2n minus n square. It is a polynomial, right? Generally we write from n square onward, n square minus 2n plus 1, something like that. But it is the better style of writing a polynomial. Can you tell one example? Polynomial, one example. Sorry? Ganesh will tell now. Ganesh. N you tell. Very good. N cube plus 3n square. Is it necessary that every power of n must be used? No, I can skip some of the powers. So I can directly go to 5 for example. And not necessary that all of them should be positive. Some of them we can take negative also. We can take coefficients as fractions, but power should not be fractions. What about 1 by 2 plus 3n? Is this a polynomial? No. If you write it in the form of 2 plus 3n whole power minus 1, you will have binomial expansion. But that binomial expansion will have negative powers, and hence it is not a polynomial. I hope you are clear now. So understood what are polynomials? Yes. Okay, good. So understood polynomial. That is not to be recorded. That's why I wrote. That is from the background. You need to know what is a polynomial. So the question is coming like, first of all I need to explain about what is limit to, come on, comparison test. Now I'll take just 2 minutes to explain what is limit comparison test. Only 2 minutes. After 2 minutes I will expect somebody of you to repeat that, right? Be careful. I expect this from you. Limit comparison test. If sigma un means one series, and all of you be careful, in the first beginning 90% of this unit 1 of infinite series, 90% we will deal only with infinite series of positive terms. Series of positive terms. Every term will be positive, we will be writing plus in between, every term will be positive. That is called a series of positive terms. At the end of the unit, we will be taking that series where terms are alternately positive and negative. Negative, positive like that. Positive, negative. That is called alternating series. That is at the last topic, okay? That is the last topic, alternating series. That is like 10% of the unit. What is 90% of the unit? Series of positive terms. These all tests which we are writing here, they are limited to series of positive terms. Now comes this one, limit comparison test. If sigma un and sigma vn are two series of positive terms, and there are two series, what I will do is, I'll pick up un from here, I'll pick up vn from here, I will divide this, I'll take this ratio, I will calculate the limit of this ratio as n tends to infinity. I will calculate this limit. Suppose the limit comes L and that L is not equal to 0. Whatever L is there, that is allowed. Negative number, positive number, fraction, okay, square root, whatever it is, it should not be 0. If it comes to 0, this limit comparison test fails. It will not tell anything. So if it is not equal to 0, carefully see, I said if here, then all these details are there. Then this if and then you handle very important, right? You cannot shift anything from here to this position after then, and you cannot shift anything from this position to that side. It is very important. Be clear about it. If this all things, then this test says sigma un and sigma vn are of same nature. Same nature. Nature means convergent or divergent. So this test says that both will be convergent or both will be divergent. It is not taking the guarantee whether they are both convergent or both divergent, but it is saying that both will be of same nature. It happens when you go for shopping. For example, you saw one item, you asked how much is the cost of that item. That storekeeper said it is 550, suppose 550. You again you have shown another item, what is the cost? Sometimes you will get the answer same cost. He will not even tell 550, he will say same means what is the rate of this, that is the rate of this. So what is the nature of sigma un? That same will be the nature for sigma vn. Now still you may not be much clear about it, how to use this test for checking the convergence of a given series. So that needs very special attention now. That is, sigma un is given series. Very important point to be noted. I am making like this, right? This is a very important point. They will be giving only one test, one series, and our question is to decide whether it is convergent or divergent. So given series will be sigma un. We will select one series from our side. How to select, that I will explain when the problem comes. So what we will be doing? We will select Vm from our side. Un is given, sigma un. Once we do that, we will calculate un by Vn, limit applied, some number will come. If it is not equal to 0, then this test says both will be of same nature. When both are of the same nature, if you decide about one among them, the other will be getting decided. But what about sigma Vn? Sigma Vn is selected series by, or selected by us. Sigma Vn is selected by us, right? How to select, I will tell you in the problem. So when we have selected it, we should know the nature of that or not. We have selected, we know that it is like this. We will select only that series whose nature we know. So what we will do? We will select this sigma Vn. We know about it. If it is convergent, we will say this is convergent. If this is divergent, we will say this is divergent. Is this point clear to all of you? I will just give the conclusion. If sigma un and sigma vn are two series of positive terms and limit of un by vn is equal to L some number that is not equal to 0, then sigma un and sigma vn are of same nature. The given series is called sigma un. We will select one series that we call it as sigma vn. We will calculate the limit of un by vn. If the limit comes not equal to 0, this test says they are both of the same nature. This is selected by us, so we know the nature in advance, and then we will declare the nature of the sigma un. And very simple and special point is that the series sigma vn which we are selecting is one of the two only, geometric series or harmonic series. So when I select a geometric series, I know it is convergent or divergent under what condition. If I select P series also, I know well in advance. Now tell me what is sigma 1 by n square? Convergent, because P value is 2. 2 is greater than 1. What about sigma 1 by 3 whole power n? Sigma 1 by 3 whole power n. R value is 1 by 3 less than 1. Therefore it is convergent. So what type of series we will select? Either geometric series or... Now there are so many geometric series and there are so many geometric series and so many harmonic, which we have to pick up. That depends upon the given problem. How to make up or how to prepare that Vn depending upon Un, we will see a problem. Is the point clear to you? Now, anyone who can repeat what is the limit comparison test? Actually, I have given the conclusion also. I expect from you only this sentence. Limit comparison test. It starts from here, ends here. Only this much are of the same nature. Can you repeat it? Who is ready to repeat? Please raise your hand. Just still it is not digested or not stored in your memory. You can tell, no? No? Please tell. Don't see that. Series of positive terms and this and means this is also a condition. Limit. Good, very nice. You had sigma here also. Sigma un and vn you said, right? Sigma un and are same nature. So very nice. Good. I was expecting and you said it. Please come and take the photo. Okay. Now what we are going to do? We are going to see problem on the limit comparison test. At least if you do one problem, you will get the idea, no, how to apply the test. Then we will go to the other two tests. So first we will see how we have to apply limit comparison test. Do you remember when we have to apply this limit comparison test? When un is in the form of polynomial by polynomial. Enough. Now the question is coming like this. Test the convergence of the series sigma n by or 4n by 5n square minus 3n plus 10 suppose. I will not write here n is equal to 1 to infinity, it is understood. Let it be plus minus, no problem at all. Only see that denominator should not become 0 when you substitute n is equal to 1, 2, 3. I am trying to write each and every step in a very formal way, right? So you have to start up like this. Given series is, what is the given series? Sigma 4n by, and I will give you one shortcut to you, that is, if the degrees of these polynomials are same, don't touch limit comparison test. There is a shortcut available, we will see that shortcut later on. When the degrees are not equal, then only you touch this. And if the degree of the numerator is greater than the degree of the denominator, simply write it is divergent. If the degree is less here, then better you use and show that how it is. Is this okay? I will call this as a sigma un. Say. So what is un now? Un is equal to 4n divided by 5n square plus 3n plus 10. Now comes the important instructions how to prepare Vn from a given un. That is equal to, what is the highest power of n here? Only n power 1. Just take it as common. Highest power from numerator. That is n common. What is the what is remaining? 4. You take n square common from here. Individually take highest power of n separately from the numerator, separately from the denominator. over. What is remaining now? 5 plus 10 by, you multiply, you will come to know it is this much. I think I should not write after this. They are having problem in the last benches, right? Okay, good. Enough. Can I write just one step more? Only one line. That is, if you cancel this, what comes? 1 by n. Whatever net power of n remains in the denominator, that complete you take as Vn. So let Vn is equal to cancel 1 by n. So just in these two steps, are you able to decide what is Vn? Over. Once you decide Vn, just look at this. Apply sigma. Apply sigma here. Sigma 1 by n is divergent. P series, no? P value is how much? 1. It is, this is divergent. So sigma un is also divergent. You can say that, but you need to show to the public that you are applying limit comparison test, and that is applicable only when the limit of un by vn is not equal to 0. When the limit of un by vn becomes equal to 0, you cannot use that test. So only what is remaining, it is only remaining to prove that limit of un by vn is not equal to, so extra complete work is going on only for that part to prove that the limit is not equal to 0. So this is vn, this is un, implies un is this. What will be un by vn? This whole divided by this one. So this 1 by n gets cancelled. So this is the net result. So what I will write now? Now limit of un by vn is equal to limit n tends to infinity. What is un by vn? Very good. This complete leftover part. So 4 by 5 plus 10 by n square. You all know one thing, that this limit gets separated for the numerator, and when you separate for the numerator, it is a constant. So n will not be applicable there. Constant limit is constant itself. So it is 4. When you separate it for the denominator, there are 3 terms. So it will be separated for the first term, second term, third term. When you separate it for the first term, it is a constant. Therefore, constant limit is constant only, 5. When n tends to infinity, 1 by n tends to 0. 0 into 3 is 0. So whenever the denominators are n square, n cube, all these things, you just go on replacing with the zeros. So no need to write 3 into 0. Directly I suggest you write to 0. And this is 0. So what is the value now? 4 by 5. Only what you need to check, is it 0 or not? It is less than 1, greater than 1, that game of geometric series and P series is not involved here. This limit of un by vn should not be equal to 0. So it is not equal to 0. Therefore, by LCP, what can you do? What can you say? Sigma un and sigma vn are of same. This test is not taking the responsibility of one of the two. Directly it is saying both convergent or both divergent. But we know, what is that we know? That sigma vn is equal to sigma 1 by n. Why so? I written vn as 1 by n here. I am just applying sigma to both of them. So sigma vn is sigma 1 by n is divergent. Why it is divergent? Comma, since it is P series and P is equal to 1, that is why it is divergent. Therefore, sigma un is also Divergent. When it is divergent, what is divergent? Sigma un. But this sigma un is a name given by us here. What is that? Given series is this. That is equal to sigma un. So this sigma un is nothing but this one. Hence sigma 4n divided by 5n square plus 3m plus 10 is also, listen carefully, the divergence is, or convergence, better to say convergence, means whether it is convergent or divergent is getting decided here only, right? But it is formality to show that you are applying limit comparison test by showing that limit is not equal to 0. But here itself you can decide it. Simply, I will write one more expression. You can just see and tell. No need of calculation, nothing. Sigma n square plus 1 divided by n to the power of 4 minus 3n square plus n plus 5. Anyway, no problem at all. What is coming common from here? N to the power of cancelled 1 by n square. So Vn is how much? Convergent. So this is also, but you don't declare here itself. You have to calculate the limit and show that it is coming not equal to 0. I hope you are clear about this. Please come. What's the name? Hey, don't say here. Tell the name. He will tell the name. What's the name? Okay. Please take the photo. How many of you are clear about the limit comparison test? Everyone. Raising the hands, no, these many. Some didn't listen what I asked. That is why they are not raising the hand. Good, thank you. Last benches also raising the hand means the audio is okay, up to here, okay. So if one or two students says, even if one or two students says that they understood, means explanation was okay. Do you remember what is the name of the second test? Or leave it, you just tell ratio test. Full name is parameters. In short, it is ratio test. Only this ratio test. What is the conclusion of that test? There two series are involved. One is given series, one is selected by us. But here, this test is just handling the given series. We are not preparing from our side. So it is so simple test now, that is, if sigma un is a series of positive, I'll be mentioning every time that it is a series of positive terms. If it is alternating, don't use ratio test. And limit n tends to infinity, whatever un is given, for that un you calculate un plus 1. What is meant by un plus 1? In the place of n substitute, so some un plus 1 will come. Divide that un plus 1 with, okay, can you do un plus 1 value, can you calculate or not? You can divide it. That net fraction, you apply the limit. Let that limit is equal to L. If this all, then be careful every time. I am giving special focus on if and then. If these things, then conclusions are like this. Number 1, sigma un is convergent. Convergent if this L comes less than 1. So it is very carefully to be noted that this limit plays very important role in deciding it is convergent or previous limit comparison test, whatever number comes, you least bothered, it should be not equal to 0, enough. Here it should be less than 1, convergent. Second, sigma V, same un, no Vn here, sigma un is divergent if L is greater than 1. Now a normal question comes, what happens when L equal to 1. Okay, if L comes to 0, what is your conclusion? Convergent. L is less than 1. No. If L comes 3.5, if L comes 1, you should not tell, you don't know, I have not written the condition. Now I am writing the condition. The test fails. The fails. 2, test fails means it is not that from today onwards ratio test is out of the game. Not like that. It is failing to decide the nature of sigma un. Understood? For this problem it fails. For another problem again it will be active. If this fails, what to do? There is a common natural question. Then the answer is, there is one test called as Rebbe's test. R-A-A-B-E'(S). Rebbe's test or Rabb's test. Anyway, pronunciations that does not matter for mathematics people, right? I hope. Some excuse. When the ratio test fails, we will apply. If Rebbe's test fails, some other test. That some other test is not in your syllabus. I will not even speak the name of the test. When it is not in your syllabus, I should not talk about it. So keep in mind, this is to come when ratio test fails. Is this clear? We will do a little problem, small problem on this one. So, question. Test the convergence of sigma 1 by n factorial or 2n whole factorial. 2n whole factorial. Acha, whether anybody got the doubt, when should this be applied? Anybody got the doubt or not? I said when your numerator and denominator are polynomials, best choice is limit comparison test. Some other situations also we can apply, but in that situations when numerator and denominator are polynomials, the best choice is limit comparison test. When this test to be applied, then slowly I will be telling you the conditions. Number 1, when factorial comes, the best choice, the only choice, best and the only choice, ratio test. Factorial is visible, no other second choice, only ratio test. Solution. Given series is sigma 1 by 2n factorial. That is equal to sigma un, say. Is it coming in the coverage? Yes. What is un then? 1 by 2n factorial. Okay? It's like this. Next. What is un plus 1? 1 by 2 into n plus 1, this whole factorial. That is equal to 1 by 2n plus 2. 2n plus 2 factorial. You know, I think about factorial. What is 7 factorial? 7 into? I am not interested to write from 5 up to 1. I will simply say 5. Is it allowed? You have to go on decreasing 1 1. Wherever you feel that you want to drop it, you write that factorial. Okay, enough. Now, what is this here? 2n plus 2 into 2n plus 1, 1 less, into 2n factorial, right? So, please come. Because if I write there, I think it will not come. I'm troubling you every time. Thank you. Okay, good. What is the next continuation? That's equal to 1 by 2n plus 2. Don't write 2n factorial. It is confusing. Whether this factorial is applied when 2 is multiplied or totally factorial is taken. So 2n whole factorial. This is u n plus 1. Now, limit n tends to un plus 1 divided by un. This is limit n tends to infinity. Come on. First of all, you write the value of un plus 1. 1 by 2n plus 2, 2n plus 1 into bracket 2n factorial into this denominator un will get reversed. So reciprocal you have to write it. So 1 by 2n factorial will become 2n whole factorial by 1. Okay. So that is equal to limit n tends to infinity. This part gets cancelled. So left over is only this part. That is 1 by 2n plus 2 into. Okay. Now we have to apply the limit for this. When you want to apply the limit for this, be careful. Limit n tends to infinity. Shall I remove this one? You have taken the photo for this one. Listen, there is a chance of misunderstanding here. That is, I said in limit comparison test, take the highest power of numerator separately, highest power of denominator separately. That is to select Vn, I said. Now, coming to the point to calculate the limit, always select the highest power from the numerator and denominator. What is the highest power of numerator and denominator? Here it is nothing. Here it is n and here n square. So the means 4n square will come. So n square is highest power. That highest power you have to divide with the numerator and the denominator. So what I am doing now? I am dividing the numerator with n square. So 1 by n square. Clear about this? Okay. Denominator I have to divide with n square. That n square, 1n I am dividing here, 1n here. So I will be just simply writing 2n plus 2 by n and 2n plus 1 by n. However, I am dividing with n square. Just to split it for the sake of convenience. For the next step. Limit n tends to infinity. 1 by n square divided by 2 plus 2 by n, 2 plus 1 by n. I hope you are clear. So when you separate the limit, it is 0, 2 plus 0, 2 plus 0. It is finally 0, 0 by 4, that is 0. This 0 is deciding factor, this number, it is less than 1. Therefore, don't take responsibility on your shoulders. You say by ratio test. What is that? By ratio test given series is convergent. Since L is equal to 0 is less than 1. This L is equal to 0, whatever limit we got it. I hope you are clear up to here. Okay, please come. Next. What is the next test? Root test. Root test. Root test is 90% same like ratio test. So I'll go a little bit faster. That is cautious. What is the short name? All of you try to see what is the similarity, what is the difference. If sigma un is a series of positive terms and limit n tends to infinity, un whole power 1 by n is equal to L. Then first bit, sigma un is convergent if L is less than 1. Sigma un is divergent if L is greater than 1. The test fails if L is equal to 1. Everything same, only calculation of the limit is different. Here you are taking un and whole power 1 by n. This test to be applied when un contains n in the power, so that n and 1 by n will get cancelled and you will get the net result, which is easy to calculate the limit. So when this test should be applied? A small and a little problem, test the convergence of sigma n is equal to 1 to infinity 1 plus 1 by n whole to the power of n square. So what is the solution? So simple. Given series is n square. Whether power is involved in terms of n? Yes. So best choice is root test is equal to sigma un. Say sigma un. Say what is un? 1 plus 1 by n whole power n square. Implies what is un whole power 1 by n? 1 plus 1 by n whole power n square. This whole to the power of 1 by n. N square means n into n. N square. This is n into n. One n gets cancelled. One n remains. So it is how much now? 1 plus 1 by n whole to the power of. I should apply limit for un whole power. Implies this is limit n tends to infinity, this much, right? How many of you know that this limit is a very standard limit and that limit is equal to e? If you don't know, you remember limit n tends to infinity 1 plus 1 by n whole to the power of n, that is equal to e. What about e value? 2 point. It is greater than 1. Therefore by root test given series is. This question was asked several times in the examination for 2 marks. If it is minus n square, then it will be minus n square here. it will be minus n square here, it will be minus n here, then that n comes down, 1 by e will come, that is less than 1, then it will be convergent. I hope you understood, right? We will see about radius and all these remaining things in the next class. Let's stop here, okay? Understood? Fine. Please come and take the photo.